Hi everyone, I'm Sanmi Koyejo. Faculty in computer science. I work broadly in trustworthy machine learning and AI. Just to check that you're in the right room, this is CS329H, machine learning from human preferences. Excited to have everyone here today. In addition to myself, we have a teaching fellow, Sang. Say hello. So we'll be engaging a ton with Sang over the course of the quarter. Over the course of the quarter, you have many chances to interact with the teaching staff. So the plan today, as always for initial lectures, is sort of general overview. So we'll get into some of the framing of the course. The course is new. This is the second time we've offered it. So it was offered first last fall, and this is the second time we're offering the class. We're still figuring out exactly what this course is. So the upside is I think it'll be slightly less experimental than last time. So you guys are, you'll benefit from some of the experiments we did a year ago. But also I think there's some rough edges. So we'll depend on you for feedback on aspects of the course that you think are going well or badly to sort of further refine it. The course is sort of timely, I think, for many of us, exciting by lots of engagements or aspects of machine learning that are very explicit about using human feedback. Our goal is to engage with some of these questions, both on the application side, but also hopefully much more foundationally. And I mean foundationally in a broad sense. So both the aspects that are about machine learning, but also we'll touch on aspects that tie to things like economics, psychology. We'll play amateur everything, hopefully not too badly. Some of this will be with the core staff. Some of this will be with invited lectures. I'll go through some of this over the course of the meeting today, or the class today. Before going into slides, so one, I think, nice benefit of the fact that this is the second time we're teaching the class is that the core staff and other folks have been proactive about putting together a textbook. So we have a textbook. To my knowledge, there isn't a textbook on this topic in the world, or if there is, it's not public. So I think a unique resource from engaging in this class. There'll be a link in the slides which you'll be able to access for the book and other material. So we'll be able to see all this stuff. And it has, so it's a very rough cut. So again, be gentle, but criticize and give us feedback as you go through. But mostly today we'll go through the introduction. Over the course of the quarter, we'll go through aspects related to modeling human choice, some of the model-based techniques and preference learning. Third module being model-free optimization. And then finally, a module on human values and AI alignments. So that's the rough setup of the course, sort of intro section and then these four sections. In addition to, like I said, the teaching time, there will also be, so if we look through the syllabus, there'll also be quite a few invited lectures. Early October, so roughly at the end of every module, we expect to have an invited lecture on topics relevant to the module that we just covered. This iteration of the course is the first time we're having homework. So last time was purely sort of discussion and lecture. This time we're setting it up as 60% homework. You get the first homework soon, in about a week or so. Again, they're, unlike courses I've been running for a long time, this would be sort of fresh iterations of homework questions. So again, I'm sure there'll be some wrinkles. It's a small to medium class, so our hope is there's a lot of discussion back and forth, and we can both be sort of adaptive to the needs and what you want to learn, but also we can learn a bunch from you on how to improve the material in the course. There's a big focus on projects for a class like this. So the plan is that you would organize into groups of up to 5 students, and each group will have a series of deliverables that at the end will be a final project that will be presented at least to the class group and potentially to additional folks externally. So this seems to have worked well, and many of you have taken courses that have sort of a big project flavor. So that's part of our plan for the rest of this class. And then, as mentioned, because there's a bunch of stuff that we're still figuring out, there's a meaningful load on class participation. So we encourage you to engage in the class, either in the class itself or on the other artifacts. So there'll be aspects of, for instance, giving feedback on the textbook on GitHub. There will be aspects of engaging with questions and answers on Ed. And then there'll be, as already mentioned, in-class participation. So I think that's that for logistics. She went a little bit faster than I planned. Again, for a class like this on sort of newish topics, I think there's a lot to be gained by the discussion. So my pitch is consider coming anyway, and hopefully there'll be some value from engaging in the conversation in the class. But good question. The other thing to mention, if you're a CS PhD student, this course counts for either your learning and modeling requirements or human and society requirements, which may give you some sense of the kinds of material that we plan to cover. So now in the end, this is a technical course. So I think we'll always sort of fall back on machine learning fundamentals. However, intentionally, this is scoped as trying to think about what this means. It's about learning from humans. There's going to be a bunch of work thinking about human engagement, societal considerations, a bunch of these other broader questions. So we'll attempt this mix of broad and breadth and depth at the same time, with a slight bias towards breadth in the material. Okay, other questions? If not, yes.
I guess it would be interesting to know a little about Bell's background, like machine learning preferences with fairly new research topics.
Okay, so this is background of the instructors.
Yeah.
Sure. So I've been at Stanford a couple of years. Before that was professor at the University of Illinois. Relevant to this class, I have been working for a while on ways to get human preferences in sort of classic machine learning problems. So there's a framework we talk about briefly today as well called metric elicitation that I worked on to try to engage with these questions, strongly related to folks in, say, RL that were doing MSRL and so these kinds of ideas in the ecosystem. All of this got exciting once again, I think, for many people with language models and sort of RLHF being a thing. Again, we'll engage a little bit with this and try to place this in some context. We do a little bit of work related to these kinds of questions. There's some interesting questions on sort of academia industry for these kinds of work that I actually hope are part of the discussion as we go through. I think that's also interesting. I think that's that for my background. I'm happy to go into any more depth. Other teaching staff are free to say more about their backgrounds. Everyone has relevant experience to this, but
Feel like it?
I work on a book paper on this topic since 2023, so it's not too long ago. That's my background.
So we'll go through the material for today. Again, feel free to take a look at the textbook once you get a chance. So our goal today is an introduction and go through some of the framing of the class and maybe set up some of how we'll think about the topics as we go through the next few lectures. So the broad area is still being defined, but we attempted to mock up a definition that we can critique actually a little bit if folks are interested. But this class seeks to explore the challenge of efficiently and effectively eliciting values and preferences from individuals or groups or societies and embedding them within AI models and applications. Our specific focus will be on some of the statistical and conceptual foundations and strategies for interactively querying humans to elicit information that can improve learning and applications. So, as discussed and as framed, we'll think about, many of the questions we'll think about in this class will be sort of through the lens of the sort of machine learning question. But we hope to meaningfully engage with broader impacts of this work in terms of how it affects individual society, all these kinds of questions. The efficiently there is going to speak to some of the challenges of engaging with, interacting with people, and trying to do this with sort of as few interactions as possible. So there's a term, query efficiency. We'll talk about this a little bit more. That tries to ask questions when you can about sort of things like how many samples would you need, how many interactions would you need to get a particular, estimate a particular function from interacting with some set of agents, and effectively thinking about the quality of the elicitation process, so getting the signal from people. Any questions on the setup, broad framing, any strong criticism or weak criticism of this, thoughts?
Yes. I'm just curious about the word interactive that you find very human. Seems like kind of implies some sort of back and forth discussion style or survey style.
Yeah. Excellent question. Yeah, so the question is about interactively and sort of why we state interactively. So I'll engage with this a little bit in a couple of slides, but one, from a certain point of view, all of machine learning is learning from human preferences. So in fact, it doesn't narrow the field at all. And the reason for this is a lot of what AI models, machine learning models are trained to do are effectively to learn from signals that come from people. So many applications of machine learning are sort of, say, medical applications, people label, or actually almost all applications involve humans creating content of some kind. And then we build models to mimic or approximate that content. So from that point of view, all of machine learning is machine learning from human preferences. There's also a much more focused, are we trying to build AI as some intelligence goal? We'll talk a bit about this in a little bit, which again, directly engages with the idea of learning from humans. Here, we're going to focus on settings where we're much more explicit and intentional about the human signal. So I think of the settings where humans are labeling data, and then you learn from that data as, in some ways, implicit. So there's a preference effect that will show up based on how wherever the data labeling is coming from. In this class, we'll focus on the subset of these questions where the goal of the learning procedure is very explicitly about learning from preferences, often through interactive processes. So exactly as you stated, we'll focus on the sort of, this seems the gap that's most interesting. This is, again, the motivation for this class and trying to think about these questions. It won't cover everything, but that'll be our explicit focus. Thank you. Good question. Yes.
I think I like it. I like the broadening of it because in so many real world AI applications, the data set is immutable, and that's just not the real world.
Mm-hmm.
And sampling from humans, like the defense we just witnessed, is humans don't agree with themselves 25% of the time.
Yes.
If you give the same exact label, depending on if you've had lunch or not, you get a different answer.
Yeah.
And so that we have Bernoulli distribution that models the actual labeling process of internal human, let alone instruct human.
Yeah.
And so I like the broadening to include that part, that system into the entire thing.
Yeah, no, this is a super interesting point. So we'll touch on this a bit. Questions like, I guess, inconsistency of humans and how to think about, or human labels in many settings. And some existing literature, ways of thinking about what this means, and how to engage with this. We'll talk a bit about models. We choose Bernoulli models. I don't know if that's the truth. So we'll talk a bit about at least some framings how to think about this issue. But yeah, things like noise and or at least uncertainty that comes from inconsistent signals from humans. Yeah, great point. Okay, so As mentioned a little bit in the last slide, so our goal is to engage with both the foundations and a variety of strategies for interactively querying humans to elicit information that can improve some kind of learning goal or some kind of application. So we'll focus mostly on sort of learning systems that have a very explicit human in the loop component with some bias towards interactive kinds of systems. We'll engage a little bit with some of the foundations. So some of these come from economics, psychology, marketing, statistics. We'll talk about applications. So front of mind for many of us are applications in language. So again, learning preferences or values from people, but also sort of long history of work in things like robotics. And I don't remember what we meant by, logistics. Yes. Okay. So explicit logistics. I don't think we'll talk much about logistics, but the applications in logistics, for instance, where, for instance, you're trying to plan delivery or routing or things like that, and you might take preferences into account and how you think through, or explicitly elicit preferences as a way to improve things like routing models. All of these will focus on through the view of machine learning. So what this means is we'll try to set up the problem, try to understand some of the angles of the problem, and then we'll focus on questions related to things like modeling, estimation, evaluation, questions within each of these problem settings. I think part of what this means, and we'll talk through prerequisites a little bit, is that there'll be an assumption that you're comfortable with the basics of machine learning, enough to sort of write some simple programs and build simple machine learning models. So, train, test, validation splits should not be surprising to you. If they are, we should have a quick chat. Logistic regression should not be surprising to you if you've taken this class. If it is, again, we should chat to make sure things would be a good fit. So again, we'll need that component, and so we'll think about this as a meaningful part of the problem. The next aspect of this, so the second arm of this, is thinking about what this means in terms of human preferences. So how do we think about humans in here? I think it's an interesting thing because depending on where you sit in the sort of ML AI world, I think we have some aversion to thinking about humans, even though humans are everywhere. So you'll see this in how many of you might, or even your colleagues, engage with some of these questions. There's an argument made, in fact, I was on a panel last week where someone made ambitious statements. They said, I don't know if this will be true, but maybe food for thought for the group. They said, within a generation, I don't know what a generation might mean, maybe 5 to 10 years, they think all of AI will be HCI. And so actually there won't be an AI thing anymore, in the sense that all the hardest and most interesting questions will be about human-computer interaction. I think there's a plausible case to be made for this. I think, we've made meaningful progress on the pure algorithmic side, and many of the questions that seem important to try to solve to get to applications or impacts that we want seem bottlenecked by how we think about humans within our deployed systems. So we'll try to think about this a bit. Again, some of this will be grounded in literature, so we'll have papers for you to read, but some of this will also be just discussion in the class and think about these questions. So a bunch of sub-questions show up, various aspects of biases I think you brought up, or questions of, to what extent should we assume rationality in the humans? Is that a good assumption? What does it break? Questions of thinking of human errors as noise, and when that might be or not be a good or bad assumption, various kinds of notions of correctness, expertise, and human engagement with AI systems. We're going to engage with questions of, so often the questions change if it's a human or a group of humans or like a broad societal context. So we'll attempt to engage in all of these questions. There's some balance based on expertise, literature, preferences, though again, it's something we're open to adjusting based on feedback from the class. So questions, for instance, if I'm interested in eliciting a preference, does the problem change if I'm trying to get your preference as an individual versus the whole class's preference? How do I deal with the fact that we won't agree on many things about, for instance, size of groups for projects? And what does it look like to think of a synthesis, an aggregation of preferences, and think about this in ways that might get at broader values? What does this look like in terms of strategic agents that may be trying to game some coordination system? And how can we, are there settings that we can build tools to engage with these kinds of questions? The last bit, but I think quite important, is that the nature of this class will mean that in many settings, we'll have to think, or there'll almost always be a meaningful ethical angle that we'll try to think through. So this shows up in a bunch of different ways. I have a few examples here. But for instance, questions of humans. So if you're building a system, you're going to deploy it, you pick who is going to give you signal and whose preference you're going to try to get the model to align with. And that choice has an effect downstream. So, which humans you're getting preferences from has some meaningful effect. Some of this, can be positive. Some of this can be tricky and look exploitative. We'll try to engage a little bit with aspects of all of these questions and not shy away from sort of ethical questions that might be part of what it means to do modern AI and engage with learning from human preferences. Okay. I'll pause for questions or reactions.
I have a question on
Yes.
the last part. As we say that we often do data sampling to where we make sure the data is coming from different scenarios and different sectors so that a model is trained to handle all sort of edge cases. Do we also will come up in this course with some kind of human human sampling where we make sure that we are taking consideration of different groups of humans for that human preferences to be actual sort of in true sense ethical human preferences from all groups?
Yeah, this is a great question. So it's a question of, if we're framing this question in terms of ethics and maybe representation across different subgroups, are we going to engage in methods that allow to think about this question carefully? We'll touch on it a little bit. So we'll have at least one lecture that engages the question. I don't think deeply enough. And I think this is actually a really good. So I don't think literature is complete on this question. There's a bit of work. We'll, I think, add to references some of the work, given the interest, that thinks about versions of this human preference learning when you have different groups and thinking about this question of, say, representative sampling, or other ways to think about balancing preferences across groups. But I'll also mention that I think this is one of those areas that the field, at least the MLAI subfield, is fairly early on. Other folks have thought about this a bit. There's some work in economics. There's sort of work in ethics broadly. You're thinking about these questions. I think it's a great project direction if you're thinking about projects. Ways of engaging with getting preferences across diverse groups. That's a good question. Okay. Yes.
Just along the line of individual sampling, is there an intersection between this type of work and low data machine learning? In case of very high fidelity but low.
Yeah, this is a fascinating question. So the question is, I guess there's a whole literature on learning with limited samples and so limited data of various kinds. To what extent are we going to engage with that? So I think this is a good, I hadn't thought about this very specifically, so I actually like that question a lot. We'll engage with this implicitly because in almost all settings, the learning problems that we'll set up will, by construction, require learning with limited samples. Again, engaging with some of what I mentioned before about the querying humans can be expensive, and so we're often under some budget constraint on sample size. Yeah, it would be good to actually think about maybe being more explicit about that part of the framing. It'll be implicit in problems. We hadn't planned to be that explicit, but it's an excellent question, and it'll show up everywhere. So almost all settings will need to learn with limited data. We'll be using some of the tricks of the trade, so pre-training, foundation models, all that kind of stuff. Great question. Thank you. Yes.
You mentioned it would be a good topic to explore for the final project. It made me wonder, are most of the final projects like coding projects that are outputted, or are they more research on like theoretical questions, or what's kind of the scope of that?
Yeah, we'll have more. So this is like, what does the project look like? We have a pretty wide breadth of things that would be considered good projects. We'll try to give feedback all the way through. We will have documentation this week as well, saying a bit about our perspective on what makes a good final project. But to your question, theoretical research makes sense. Critical examination of a field makes sense. In some settings, literature survey might make sense. Though lit surveys are harder than people give it credit for. I'll just say that up front. And people think it's an easy way to engage. I actually think a good lit survey is quite hard. Or technical science, technical research with sort of a code or some other program artifact. All these will be in scope. Yes. Okay, and also applications. We think about, this is an area that seems to touch lots of different application areas. So, I think most of you end up, at least from limited one quarter of experience, and also just the zeitgeist. I think most people will end up doing language, but vision makes sense, RL makes sense. There's a really fun application. I'll see if we can get someone to show up, but there's some applications in sort of legal and policy that I learned about recently that are kind of cool. So, a bunch of different areas that you could imagine applying these kinds of tools. So feel free to expand, explore, all that fun stuff.
There was the project from last year is still up on Medium.
Oh, okay, yes. We should add that link somewhere.
So if you want to find project from last year, you can. I can forward over. It's searchable on the internet.
Cool. Everyone searches. It's great. Okay. Okay. So what else to say? So, this is a emerging topic in some ways. I think the edges of the topic are unclear. It's also broad. We're not going to try to be exhaustive. We have some breadth bias, so we'll try to cover lots of different topics. But we don't expect that we can cover everything that's relevant to this question. So, some other aspects of this. So I talked about this at the beginning a little bit, but in some ways, all of AI you can think of as learning from human preferences. So in some sense, it's a catch-all. We'll avoid lots of that part of the problem. There's also, beyond the data itself, people in this room are the people who actually build machine learning and AI models. It's sometimes underappreciated how individual decision-making and choices actually has a meaningful impact on what the actual models that come out of sort of some production process. So, you're making choices about which problem you actually want to solve and what's feasible, where you're going to go look for data, what kinds of architectures, what kinds of loss functions, what kinds of optimization algorithms. All these are sort of individual decisions that have a meaningful impact on AI models. So again, if you want to go to catch-all, this is a kind of learning from human preferences, because as a designer, you're making preference decisions about the algorithm, for instance, the data, the loss functions. This is not what we mean, but want to say that this, I think, is also like a meaningful way of thinking about these kinds of questions. There's a bunch of work on things like model architectures. So, beyond high-level problem definition, but even things like how one builds, most commonly in graphical models and causal inference, where you put a lot of inductive bias in the models, but even more general framings often use expertise in various ways. People have argued, for instance, like convolution neural networks were a thing because people noticed convolution was a good inductive bias and sort of matched to things about human vision, for instance. So there are many ways that you can think about expert knowledge and inductive biases. Again, we're not talking about that, but want to mention that this is important. And then we'll touch a little bit, but we won't go into any meaningful depth on HCI problems broadly. I think it's super important. The gap is partially expertise, partially scope. So we won't sort of do super deep dive. I would say, though, experience or interest in HCI will generally serve you well if this kind of topic is something that you're interested in. So, questions about interface, questions about process, questions about things. Some of these are the rote things like how do I design a study and get IRB approval. Many in the building or actually on campus don't know how to do this because we don't do it that often. But if you're going to do work like this, particularly if you're going to actually query humans, that kind of experience can be very helpful. So some of you, I expect you might consider projects that engage with those kinds of questions, encouraging that as something you might think about. Okay. So just thinking broadly, again, this broad framing of human feedback shows up everywhere. So I'm showing a nice figure out of a recent paper, borrowing some slides from colleague D, talking about how human feedback shapes a lot of the explicit machine learning process. So as mentioned already, but things like data selection, labeling, model selection, training, evaluation, deployment, context. There's a bunch of good work taxonomizing ways that human human preferences end up shaping what we're building in machine learning models. Again, I won't talk too deeply about this, but I want to mention this for grounding my statement about human preferences playing a big role in lots of what we do when we're building models. So all the way from how we construct data sets and how we might think about questions on things like synthetic data, for instance, often have explicit and sort of judgments and decision-making within it, all the way to things like how we specify constraints of various kinds or real-world constraints embedding into models, various ways of adapting models, and so forth. And so I'm mentioning this also because, again, out of scope for this class, but there's a bunch of work that thinks about ways to capture human preferences to engage with everything on this page. So there's work on elicitation mechanisms for constraint specification, for instance, which we're not going to talk about that much, but I think is a sort of very important subset of problems for various, for instance, in logistics problems and planning. Okay, so examples and applications. I'm hoping some of this also to learn from you, because I often learn some cool new things from this. So just get the elephant out of the way. ChatGPT got a lot more people excited about what it means to learn from feedback. In many ways, it's been argued, depending on where you stand, it's this revisionist thing. Did we expect it? Did we not? I don't know. But of the many innovations that got this to work, in the sense of people getting good experiences engaging with a language model, it's been argued quite strongly that a lot of the work on trying to align to human preferences via things like RLHF made a big difference. So I think, again, some of this reinvigorated interest in this area. And a lot of this work builds on long history of work. So a lot of it, particularly for language models, and various mechanisms for capturing feedback in building language models. So I think there was a comment or question earlier, but things like document level interaction, label consistency queries from humans or experts, word level interaction. So I have some language model. Can I have a human tell me which terms are most influential or label those terms within language system? Can a human help in thinking of which features to add or remove based on what we think might be important? So again, still an important part of most sort of ML ops frameworks and like large-scale deployed systems. Some human intuition about what might be important features. All the way to things like humans trying to help select model parameters, thinking about both the measurement and then sort of feedback on where models are doing well or failing, and using that signal to improve or explore across ranges of models. Examples of this, so versions of this. So again, the references are in the slides. Feel free to take a look. So things like trying to improve parsers by labeling connections between different words. Pat ate the cake on the table that I baked last night. and the parser might say, I baked the table because it has incorrect interaction between the term and sort of the noun that is supposed to be labeling, and you might correct this. So human understanding that I baked the cake, and you might include this within a language model system as a way to improve its quality of parsing. So for instance, getting parts of speech correct, or just more generally trying to get so the right structure in examining or explaining a sentence. So, some of these are still important problems that are worked on independently. Arguably, lots of these things language models seem to be much better at without as much explicit intervention. But some of these questions I think are still quite interesting. Think about how to frame, and some of these papers explicitly think about how to get feedback efficiently from people to improve systems that look like this. Okay, so other big line of work, trying to engage with, so we'll spend some time on this going through in some detail, but it's useful to look at some of the early descriptions of some of the work trying to improve learning from human preferences. So as many of you know, in the standard framework, we start with supervised learning from humans. So humans, I'm talking about language models now to give some context. A language model, as many of you know, you start with some pre-training. Generally, you train a model to do a good job predicting next words on web data. Once you do that, the common next step is supervised fine-tuning, where you get examples of sort of knowledgeable, or at least, or generally somewhat knowledgeable humans, give examples of questions and answers that might be relevant for a certain query. And then you get these as sort of specialized examples. They're typically much smaller. So, web data, this is huge. In terms of token counts, you go down to something on the order of often thousands of examples to do supervised fine-tuning, where the objective is still the same. It's still doing sort of next word prediction, but the model gets better at question answering in general from this part of the process. And then the next step is generally this comparison data. So this is thought of as querying humans to get some kind of preference signal between different kinds of completions to a certain query. There are various ways of doing it. Sometimes the most commonly used approach is pairwise preferences. So I ask a human, I have some query, I have a set of different completions. I ask a human what they prefer, which of the completions they prefer. And then I train some model to sort of be better at responding with the preferred response, I guess, from either the pair or a set. So for instance, if you have 4 different possible responses, then you might ask the person to pick between the 4. Typically, this is discrete choice. Typically, again, these are somewhat limited sets of samples. In this class, all of these are important in training language models. We'll spend a bit more focus on the sort of step 2 version of this. So again, this interactive. I think of the step 1 as mostly one-shots. So there's a bunch of work offline to query a bunch of people to sort of get good completion examples. Section 2, the step 2 is typically is best done interactively. Actually, it would be good to engage with some of this. In the sense that some versions of this work do stuff interactively, some versions do stuff offline. We'll dive into some of the technical details of those differences over the course of the class. But in either case, you get examples, people label them in terms of preferences. You can think about this narrowly in terms of narrow preferences for completions. You can think about this more broadly as maybe embedding values somehow in terms of what they think a language model should be doing. We'll try to engage in both of those perspectives of this question. And then the next step is sort of optimization step. Typically 2 and 3 are done together, which is a combination of the various mechanisms. The most popular one is using reinforcement learning strategy, so something like a PPO algorithm. We'll touch a bit on this, combined with trying to get preferences through interaction. And over the sequence, the model gets better at getting high rewards. So it gets better at sort of picking or choosing a completion that's likely to be the same as what a human expert would have picked. Okay, any questions on the discussion so far? We've outlined some of the literature, existing work, particularly within language, particularly within that has engaged with thinking about learning from human preferences. Any questions so far in the framing and how we think about topics? Yes.
Yeah, how much will we do of like step 3 in terms of like training policies with the reward models?
Yeah. So the question is, how much will we do of step 3? How much are we going to implement, for instance, RLHF? The plan is a meaningful amount. I don't know how to answer that question actually more accurately than that. But our plan is to include implementation. So we'll build, the plan is to build some systems and actually test things like this, DPL, other ways of doing sort of pairwise preference.
Like on language models?
Yes, on language models.
Yeah, so you have some work on homework, and definitely on project if you chose to.
Yeah, it's a good question. Okay, other questions or if anyone knows of other interesting applications that have similar flavor of human preference measurement to improve algorithmic systems. Maybe your favorite example. Yes?
I was wondering if like reinforcement learning from AI feedback would be like a topic.
Yeah, it's a good question. So, as a contrast to learning from human feedback, there's also now work thinking about AI judgments. So, for instance, language model judgments as ways to improve models. We don't plan, given the thesis of this class, we don't plan to spend a lot of time on those. Often the techniques, at least the machine learning part techniques, are effectively the same, with some differences in the query mechanisms. So I think stuff will transfer over reasonably well, but the plan is to focus much more on human feedback. It's a good question. Thank you.
We have like GPUs to work with or runtime credits.
This is a good question. So the question is, are we going to have GPUs or credits to work with? Working on it slower than I would like. Almost definitely have something. The size and scope is not yet clear. But we'll try to figure this out before any meaningful computational homework or projects. Good question. It's the bottleneck of academic work in this space. It's compute almost always. Yeah.
Are the homeworks primarily implementation focused?
Yeah, so other homeworks implementation, our plan is a mix, some conceptual, a fair amount of implementation.
So in a lot of research, like pure ML research, people don't usually go to like steps 2 and 3, where maybe it's like model architecture and still just do pre-training plus SFT. So I'm curious, are there specific applications where like human preferences are just avoided? Or at like industry level, it's always done, but on the research side?
It's a great question. So the question is, a summary of the question. Many ML applications don't do very explicit human preference. Is there some gap between, I'll frame this as research versus academic work for many kinds of questions. So indeed, there is more, most of the published work that engages with sort of real world learn from human preferences, at least in the machine learning literature, tends to be from industry. I think there are a variety of reasons for this. One of it is a bit more challenging to do a good job of sort of collecting human preference data. Partially, you have to go through a bit more process. In many companies, either the process is lower overhead for various reasons, so we don't need to delve in details, or we can, I don't know. the processes are managed by, there's a bunch of people that will do the process for you. And so it's sort of more straightforward. It can also be expensive. So, in many versions of this, you want to pay the people that are giving you like signals or preferences, or particularly the SFT one, but even the preference one. And so, for many academic research things, in some sense, GPU is a sunk, or like compute is a sunk cost. It's sort of amortized in. This is like an additional thing, and people don't always do it. There are a few data sets out there, and I think we'll use some of them. So like pre-collected human preference data sets that one can use. And I think we'll frame a lot of the work in the class around either synthetic or like existing data sets. I think some of these blocks lead to this gap. It's like who is actually doing the work. Our hope here, so we'll engage with some of these topics. I think our hope here is to build enough foundations such that like the more one has to do some of these applied things, the gap is lower. Sort of like what you need to do to actually get things off the ground is easier. The explicit question was about like specific applications that are engaged with differently. I'd say, most interesting big language models are not academic models. There are a few outliers. There's something out of this company out of Seattle. I forget. They did OMO. AI2, yes. And there's some work here that's trying to do sort of meaningful large-scale language models with end-to-end everything. But that's a big one, a very obvious one. That just not that much end-to-end with all of this process. That includes collecting human data. A lot of it will use existing data. So like DPO, for instance, which is, we'll talk about this a bit, but famous work engaging in some of these questions, use some public data.
One question. Are these reward models or the RLHF some like open source model which we can plug into any model, or it has to be custom built to, say, a language model or a vision model that we're building?
Yeah. So the question was, are there good downloadable RLHF models, or essentially do we need to build our own? This is a great project question. So this is an interesting one in the sense, so there is now more effort in trying to publicly share reward models. There's this reward bench thing that who gave a talk last year is building, and sort of a few sort of public infrastructure to engage with this. So a lot of the space, the reason I mentioned this is a good research question is I think in language in particular, a lot of the signal is that training a reward model separately and then training a language model to fit the reward model tends not to work all that well. The most successful implementations actually updates both the language model, like this whole process. So you collect data at the same time as you're improving the model.
With the kind of model you're building?
Yes. So actually, I can just mention. So almost always the reward models are you take your language model, you cut off the head, and you put on a sort of classifier at the end. We'll talk about specifics and what this looks like in a few lectures. By next lecture, I think we'll have enough grounding to understand this. And so mechanically, it's some big, unwieldy, like as big as your language model. Procedurally, it's not fully known why you can't plug and play language models that well with reward models. So there are a few hypotheses out there. I think it's sort of active, interesting research. Again, I think an excellent potential project. And particularly if you look at public ones or public data, trying to ask some questions about why they break sometimes when I try to sort of take a language model separately, take a reward model separately, and sort of try to stitch things together. In practice, these are often trained quite close to each other. There's a few explanations in the ether, things like, is this a distribution shift issue? Should we think about the reward models actually learning human preference or just getting sort of a local approximation that's good for updating the language model? I don't think we know the answer. So very much frontier of the research space. I think a great, another project idea. So actually, we don't need previous years. I think from this class, we'll probably have enough of these. Yes?
So you said some recent somewhat recent work that does away with explicitly learning the reward model, like DPO.
Indeed.
So do you think there's still a case for learning the reward model explicitly, or is this just
Another fascinating question. Another great research project. So I'll chuckle to myself. So we'll talk about this a fair amount. So in fact, the way we set up the course material, there's a whole section on sort of learning from human preferences implicitly without, so things like pairwise signals, but without an explicit reward model. So things like DPL will show up there, but other kinds of, so things like bandits will show up there as well. And then other ways of thinking about learning from human preferences that are explicit about learning a reward model and then using that as part of the optimization process. Depending on the setting, I think the community is pursuing both. Purely computationally, it's much cheaper not to have a big reward model because they tend to be big, at least how currently they're implemented, sitting around when you're building these. In RL also, in settings where people can get away with things like behavior cloning, they try to. This is essentially treat the reinforcement learning problem like a regression problem, and you don't explicitly have a reward model. As a perspective on the problem, I think it's valuable. The reward model itself is valuable as an artifact because it hopefully tells us something about human preferences that we can then maybe examine offline, and it's also useful for evaluating it itself and what it's doing. Most of the field doesn't take that view. So the reward model is only useful in as much as it helps you train the sort of the learning model that you're interested in. And so if you can get away with training a learning model without an explicit reward model and you get similar performance, then many implementations would do that. So I guess a short answer is you don't need it. In practice, many people would prefer not to have it. I think it's valuable, but it's much more of a conceptual philosophical view than something that I have a great sort of practical answer for. I think it's one of those things where in addition to getting a signal about the model, it can also give you signals about where things might be breaking. Actually, be curious because there are experts in this room. If people have either alternative opinions or expansions of this idea, sense of, yes.
I'd say you're 100% right that people aren't using the reward model for anything but getting a better agent up until O1. And O1 is just using infinite monkey, where I just sample 1,000 and then use a smaller reward model to arbitrate between 1,000 samples and then say, that's the one that I like, and then iterate on that. So that's where the reward model makes a lot of sense, but it has to generalize beyond the local pref data set.
Indeed.
And that's, the biggest issue is the reward model is easily hackable. If you over PPO on the reward model, it will just start outputting the.
Yeah.
That just hacks the reward model, and you don't have enough pref data set to prevent that. Other than
We'll talk a bit about this sort of overfitting in various ways from reward models. Meaningful, important points. I'll try to think. I think this is an important question that I'd love to get a better answer to because I'd like to advocate for more keeping reward models around. Another angle, so again, reward bench is motivated by this idea of examining reward models themselves to say something about what it is the models are learning. Again, if you think they're learning human preferences, there's something there. But jury is out, and I think most of the field doesn't care all that much. So again, this class is framed as learning from human preferences, whether you're explicit or not. So in some ways, we're not engaging as directly. This is not the point of view that we need to take for this. We'll talk about both algorithms that try to use both with and without explicit rewards. But it's a fascinating question, what do you actually need to sort of get at the task? Yes.
This is like an ad. Is recommender systems probably how a lot of people interact with preferences.
Indeed. We'll talk a bit about recommender systems, but were you going to say?
Oh, of examples of preference learning.
Oh, yeah, for sure. Yes. So we'll talk about recommended systems and some of the other applications. But this question of, do you need reward models as a foundational question? I think that's still open. Okay, so many of you have already seen this, but these are results from, you can look up paper, we'll have this on the slides. But they showed in some of this earlier work that with, for instance, summarization tests, you could get much better results if you explicitly used human feedback and preferences as opposed to things like supervised, like the generic pre-trained model, noisy, not that bad, not that great. Supervised fine tuning improves things a meaningful amount, and then explicit human feedback tends to improve things meaningfully further. And again, a lot of this borne out in the results and in the artifacts that we're using now. So motivation for perspective on the problem. So here are some examples, again in the paper, or you can see this in the slides, but showing human reference, supervised fine tuning model that tries to answer this question, and then a model that uses human feedback. Okay. So why do we care about this question? So it engages a bit with some of the discussion earlier. So there are a bunch of different reasons. I don't think it's uniform across people who care about this problem. One of them is sometimes you're interested in signals or like evaluations where you don't have a good explicit metric or loss function. So it's unclear what it means to evaluate progress on that setting. So for instance, if I want to build a chatbot that's funny, I don't know what the equation is that quantifies funny. Someone here might. But you can imagine getting examples from people or rankings from people that says, this statement is funnier than this other statement. And this gives you a signal that you can then use to train a model that will improve on this task. So useful in settings where explicit rewards or costs or losses are just really hard to specify. And we think humans are universal experts, or at least good experts at getting a signal for those questions. Another is settings where stakeholders care a lot about the outcome. And again, the specification problem. So things like helpfulness, questions of things like fairness, where again, there are many meaningful, maybe perhaps reasonable definitions of what good is. They don't all agree, and you want to use interaction with human preferences as a way to specify a good target, say typically across a large stakeholder group. It's sometimes useful when there's some ideal behavior, we don't know how to fully specify it, but we can use evaluation signals as a good proxy. So we'll see a bit of this when we construct sort of synthetic evaluators. We'll touch on this a little bit. And then, depending on who I talk to, there are lots of these conversations where really it's just a good proxy for, we know there's a problem, we know that humans are good at fixing this kind of problem. We don't really care about preferences. We just want humans to help us fix our issues. So, all the way from things like, model makes a certain kind of spelling mistake all the time. If it's a single spelling mistake, sure. If it's a broad range of spelling mistakes, maybe having labelers tell you, different kinds of mistakes the model can make can be more efficient or practical than trying to specify all the sort of settings that this can come out with. So, as you can see, there's a broad range. There's all the way from much more explicit interest in, say, values or preferences for their own sake. And sometimes these are reasons why we engage in this. And sometimes it's just a useful proxy for some real world outcome that we'd like to get. Okay, question. Let's see some hands. Okay. Okay, so I've given some examples of all of these. They're happy to give more. Missing gaps. Okay, so there's been a lot of progress over the past couple of years. There's, again, I'd say one of the more active parts of the ML/AI research work, but there's still lots of places where we know that we're missing something. So as many of you know, in language models, there are explicit biases that the models have that reflects also human biases to a large extent. So for instance, many of you might know that chatbots tend to like long answers and also tend to like given responses that have bullets. Apparently, these are the two strongest signals in terms of both human preference and sort of language model biases. So if you want to get a good reward score, or you want to get a human to say you could give a good answer, make the answer long and give lots of bullets. Whether or not you actually answered the question, people just, you look smarter, right? And so you said a lot, as I'm doing now. There's also lots of settings where human preferences are unreliable. So we'll talk a bit about reward hacking. I'll give a quick example in a little bit. So some of these can have reward impacts. You know, some of you know a bunch of the like news stories that came out when there were mistakes. Many of these, I guess, defined as things like hallucination, so sort of errors in the model for factual queries that can sometimes be attributed to sort of something that we're missing potentially in how we construct and train models. Okay, there's work or gaps tied to potential ethical issues. So, you know, in many settings, so there's a bunch of the work that often will require sort of experts, so things like supervised fine-tuning data, but often the pairwise preference data is often outsourced and sometimes can be outsourced to sort of settings where it's low cost to get data from individuals. The ethics here are tricky, so I don't want to say this as sort of a simple cut and dry thing, but I'd like for us to be thinking about engaging some of these questions. Okay, so you know this includes, you know, on one hand, sometimes there's actually can be a good job in certain places. In many settings, though, they're often like the places where one might outsource labor for things like moderation, but also often for training models. Can be issues or settings where the individuals that try to improve these models get to see the worst of the signals that the models can create. So, you know, signal or say images, for instance, that sort of deeply unethical in various ways, or even potentially traumatic, where you might need psychological help after doing some of this work. So, you know, challenging open question, one that our field engages with a bit, but one that, again, I'd like us to, in scope for what we're thinking about and think about these kinds of issues in this class. Okay, here's a paper I like. No need to read the details, though you can look up the reference later. There's some small chance the author is here. I'm not sure. No? Okay. It's a Stanford paper. So they did this clever thing where I thought clever, where they queried, they gave the Pew survey, some of you might know this, is a survey that people, Pew uses to evaluate like values and preferences across typically different societies, the US, different subgroups. So they gave the Pew survey to a language model. And so they asked it a bunch of different questions. It can give responses. And they tried to check sort of the extent to which any of these responses correlated with different demographic groups. So do the responses look more like, you know, someone just looking through on the right-hand side, conservative with less than high school education who makes less than $30,000 as an example. So you can do this, you know, it's a sort of perhaps straightforward survey to do. Does anyone know what they found as sort of the highest correlation group to the survey? So what opinions did it suggest that their analysis suggests that the models sort of captured the best? And it's not a trick question. It's the obvious one. Guesses?
We labeled the pref data.
Yeah. Some to the pref data, not completely though, which is a little bit surprising. But I want to state this as a location. So where in the world do you think? Guesses?
The US.
Okay, so U.S. More fine-grained than this. Yeah, so very California, very U.S., very around here, actually. So it turns out language models like to be, Californian, Stanford, Palo Alto kind of people, perhaps. Not surprising in retrospect because, again, perhaps part of the labeling is done all over the world, but there's a lot of, to the earlier point, there's a lot of intervention in the models that ties to people who generally work here, who have political opinions and preferences that match, people that live around here. And so these kinds of preferences get embedded in language models. So again, part of our goal will be understand the mechanism by which this happens and sort of process either intentionally or unintentionally. But also, I think in scope is critiquing and evaluating sort of what ends up being embedded in language models. And as you might imagine, this can have downstream impacts of various kinds. Okay, so we talk a lot about language. It's hard to avoid it, but there's lots of other stuff that you can do with preference models. So we'll talk through some examples. So there's work, for instance, this is, I think, quite cool work from some colleagues out of Caltech, where they're building an exoskeleton. So people, particularly for people who cannot walk, so have lost control of part of their limbs, their legs. They have exoskeleton that helps them walk. And part of the calibration process requires getting signals on either what either feels better or worse, or sort of some signal from the human about how well it's working, to actually calibrate the exoskeleton. And so, you can imagine asking, setting up the model some way, asking the user, is the setting good for you? And the setting here involves a bunch of these probes at the back, which have different settings across this array. And all this you have to tune. So there's some response tuning curve that you have to fit. That is somewhat personalized. So each person has some tuning curve that's specialized to them. So you have to answer this question of how do I calibrate the model to the individual? And here, the signal that seems most reliable is what the person tells you in terms of how well it works for them. And so you could try an absolute value querying. Is this 4 over 5 in terms of how good this is? The problem clear, by the way? Okay, so the real world context and then a bit of the algorithmics. They found, and we'll argue a bit in many of the applications we'll look at, that preference queries worked a lot better. So instead of saying, how good is this in absolute scale, you ask people to compare two settings of the models. And then you have your algorithmics behind the scenes that can use this pairwise preference as a way to tune this array such that you get, hopefully, the best behavior in terms of the exoskeleton walking. So we'll talk a bit about this. We'll talk about, we already talked a bit about preference feedback. We'll talk about yielding bandits, which are a way to think about bandit problems with pairwise preferences explicitly as a way to frame problems like this in a bunch of different papers where this group is engaged with. Okay, other algorithms. So I talked a bit at the beginning on some of my work in metric elicitation. So the idea here is for various kinds of learning problems, say classification problems, you want to get a signal. There are lots of classification problems where the metric of success is unclear or there are asymmetric trade-offs potentially. So there is a maybe differential cost for making different kinds of errors. This shows up a lot in, say, medical application settings where false positives and false negatives don't cost the same in terms of impact on the individual. And here, calibrating your learning problem to actually figure out the right trade-offs can be tricky. And so we've done some work over a few years now thinking about ways of getting pairwise preferences from humans as a way to tune the preference of the learning model to best align with expert feedback on various kinds of, like, typically classification problems for things like this. But we did work on things like fairness problems, learning from stakeholder groups, empirical evaluation, So we've done some work in looking at how this looks like in real world contexts of various kinds. Okay, so elicitation is interesting. Again, as I've mentioned this before, but where the individual stakeholders matter or where the trade-offs are tricky and hard to specify. And so we found that valuable. Some recent work, recent-ish, thinking about inverse decision theory. So this question, it's a similar kind of question, but in the classification setting decision theory is this forward process. I have some probabilistic model of the world. I want to come out of a decision. The inverse is I want to figure out, again, how to think of trade-offs. And trade-offs in classification problems almost always boil down to thresholds. So do I set my threshold for? If I have a probabilistic model of some behavior, what do I set my threshold for? Yes, no. If I'm going to make a binary decision, for instance. And so, you can think about this as sort of some feedback process. And we've done a bit of work. I'll leave you to read details if you're interested in ways to frame this problem and so what comes out of it. Recommendation systems, like you brought up. So another meaningful, high impact application in the sense that a lot of our world now is driven by recommendation systems. So all the way from things like movies and audio, Spotify, Netflix. There's a bunch of work in this space. This, at some point was the coolest part of the AI field. I'm dating myself a bit, but when the Netflix fries was a thing, Netflix set out $1 million for whoever could improve their recommendation system algorithms. I tried, we didn't win, weren't even close, but we gave it a shot. Like many others, everyone did sort of fairly heavy, complicated algorithms that tried to be good at mean square error. There's a bunch of work building on this, and sort of other parts of the field have tried to make this problem sort of much better specified. But again, a lot of this often boils down to you're trying to model and capture human preferences over items, so movies, objects, things that people might want to buy. There's a bunch of literature, both technical and sort of otherwise, that have come out from this. So various kinds of querying, various kinds of signals. So things like thumbs up, thumbs down, which is this pairwise thing, but on an individual item, getting pairwise preferences, ranking preferences, rating preferences. So there's a whole literature there that we'll touch on, and we'll again think about how it might apply to other things that we're interested in. We've already talked about RLHF, so I won't belabor this, but additional detail if you're interested. It shows up in reinforcement learning. Show the video. So this is work in 2008, which is the first time that people used RL algorithms from human demonstrations to, automatically or learn some policy for actually flying a helicopter. So again, this was like way ahead of its time at the time. There's some work from colleague Dorsa and some of her PhD students doing all sorts of cool things and preference learning for reinforcement learning applications. So I'd argue RL is engaged with this problem for a long time and has lots of artifacts. But we'll also try to learn quite a bit from RL settings. They've also done work, it's the same group, looking at ways to learn from demonstrations. So I won't play the video for time, but you can take a look. And I've also asked questions about how to model things like comparison data. I'll maybe show this. So this is some of you might have seen this video. So this is now famous as a example of trying to learn or specify a reward function for a game playing agent. So the model is meant to, the boat is supposed to complete a course. As you can see, it's not completing the course. It turns out it's still getting a good score. So some of you might have already seen this. What the agent learned is there's a very specific set of sort of behavior that you might repeat. It turns out that if you hit those green things at the bottom, you get a bunch of rewards. They respawn at the exact right timing to sort of hit a bunch of these bolts, hit the side, and come back and get the reward over again. So your reward function was maximize score. The agent figured out I can get a really high score playing this. And so sometimes this is called reward hacking. We'll talk a bit about this and how it shows up in ways of Okay. Ways of engaging with language models. Okay. Okay. So a bunch of factors. You think about things like, how hard is it for the human to specify signals? How do we think about correctness? What happens if there is no correct answer? And how do we think about things like truthfulness and strategic behavior, various kinds, the roles of mistakes, expertise, questions like this. In most of the work, we'll assume sort of some kind of rational human. We'll engage with this a ton over the course of the lecture, but we'll assume that there exists some kind of reward function, even if we're not being explicit about it, but there exists some sort of explicit deterministic function that tells us what a human would prefer. And we'll build a lot of our models based on this. But it is an assumption, and at least one invited talk will engage with whether this assumption is reasonable or not, and what to do about it. We'll mostly talk about sort of discrete choice kinds of things and some of the parametric models that build around that. A bit about biases, aggregation, a whole bunch of the topics that I talked about. Okay, so that's that about material. A bit on just general overview. So we're going for breadth over depth for various reasons. Again, new space, we're trying to figure out what the edges are that make sense for the class. We'll try to engage with a bunch of different applications. We have a lecture schedule, which you've seen online, though there might be some shuffling in terms of topics and speakers. As already mentioned, we assume you have machine learning basics. You can do some basic programming. If you cannot, we should chat, because I think there'll be some challenges in engaging with the course. There's a textbook, and the slides will be available, and so you can take a look. And next, we'll start on material on some existing choice models for the rest of the lecture. All right, thank you. Welcome to CS329H.